Okay. Uh, Hello, hola, and namaste, everyone. I'm your uh, Rhino trainer for this webinar, which is Computable Morphologies. Here we will have something like a Rhino masterclass, where we'll see applications of Rhino for design, for various design industries, ranging from architecture, jewelry design, product, um, yeah, everything under the roof. So we will be walking through various chapters, as you have seen, where we'll see the introduction, the moving on to different kinds of objects that can be modeled in Rhino, where we deal with different kinds of morphologies, from points to curves to surfaces and then to meshes. We'll also see lots of tools for controlling these geometries, to modifying them, and to acquire different geometries from each other. In the course of the program, we will also model a few buildings and see a few tips and tricks to model them in the quickest way possible. And at the end, we'll have a challenge, which is already explained to you, I guess. Now, something about me. Well, my name is Angad. I am an architect by profession, by training, and I have an expertise in computational design and digital fabrication. Currently, I am pursuing doctoral research, a PhD, in computational design at Universitat Internacional de Catalunya, which is in Barcelona. And I have been pursuing this for about 2 years for now, and I'm somewhere there in my research. To tell you something more about me, well, this is my very basic portfolio website where I have displayed my work. Before starting the PhD and after my graduation as an architect, I have worked in India, primarily in Bengaluru and Mumbai. Majorly, I have worked on various kinds of projects, right from residential, healthcare to hospitality. But my prime focus was on has always been on infrastructure design projects. This is one of my projects which I have sort of controlled from the inception stage to the handover, and it's a pedestrian bridge basically in Bengaluru. It is across a 60-meter wide highway, and it lets pedestrians from an IT park cross a road, and they can do whatever they want on the other side. Well, this pedestrian bridge was conceptualized as my my employment in a company called Maya Praxis, which is in Bangalore, and they have an expertise in infrastructural design and urban design as well. So this project was basically designed as a public sculpture, which acts as a major intervention in solving urban problems. So the bridge was completely constructed in steel, and as you can see, it has a very dashing, fancy red, and it's quite famous in Bengaluru. I find people often having selfie challenges on this bridge, and so now it has gained kind of a cult importance. Another one is also a pedestrian bridge, which is in Koramangala, Bengaluru again. And this one connects the exit of a major shopping mall to the shopping district. It's a smaller bridge, around 30 meters. And yeah, as you can see here as well, it also performs as a public sculpture. The beauty of this bridge was it was like a tubular truss, and and without any column supports. Well, apart from practice, I have my research often ranges between exploring different construction techniques for architectural construction, or even fabrication techniques, but mostly in the domain of computational design. So here is a research project for thin shell structures that we have developed in UIC Barcelona as part of the Biodigital Architecture Master, where we conduct a fabrication workshop every year, and we develop this structure, and we keep on versioning it. We have also published a lot of papers explaining how to design a thin shell structure, and what are the ways in which it could be manufactured, fabricated, and assembled in the end. It follows something called as mesh segmentations, and it is just an easy process of fabrication by just using a laser cutting machine. Well, the project, as you can see, it uses polypropylene sheets for its assembly. But we are planning to also use aluminium, or maybe very thin MS sheets. Well, yeah, so this is the research part. I also have a very sort of an indigenous research going on parallelly, which dives into the understanding of exoskeletons and how exoskeletons could be scaled to perform different architectural or design solutions. Exoskeletons, as you know, they are found in nature on crustaceans, and here I have modeled and analyzed a pincer of a crab, done some structural analysis, load testing on it, acquired the points, and then extrapolated another exoskeleton on top of it. So yeah, this is just like a proof of concept for this project and for this research, and is doesn't have a very huge impact yet, but right now it just behaves as a jewelry concept. I had also prototyped this using an FDM machine and typical PLA kind of 3D print. So yeah, that's almost things about me. I also conduct a lot of various workshops in India and Spain. I teach a lot of computational design tools such as Rhino, Grasshopper, also Python scripting, and various other plugins of Grasshopper for the Biodigital Architecture Master at UIC Barcelona. And I also conduct various workshops in India. I also teach as a visiting faculty, and you can find all my details on my website. So that's it about me. Okay, now moving on to things that were left from the last webinar. Okay. So in the last, in the first session, we had seen, I would say, until now, we have seen how to make points and how to make curves and how to make little surfaces from these curves in the form of pipes. And now let's see how we can apply this knowledge into something that is architectural and sort of an architectural problem that we solve from time to time. So here's a little tutorial on how to make canopies. So we're going to start in a very simple way by just drawing a line, and then we'll see how it gets morphed into various different things, and then how it gets expanded into a canopy. So let's begin. I'm just going to consider some hypothetical situations and measurements for this canopy. So I'm going to start with a line that starts obviously at the origin, and it measures something like, let's say, 50. So right now we are working in millimeters, but let's just assume that this can be scaled at any point. So we have 50, let's say, unit length line, and this is how it looks when we select it. It has the starting point and the ending point, and those points are control points which can be controlled and can be modified at any stage. So this is our line. Let's rebuild it. I'm going to rebuild this curve by typing the rebuild command and selecting the curve, and then it gives me options of how I want to rebuild it. So as we have seen before, we can have two inputs. One is the point count. So I'm going to increase the point count to, let's say, something like 6. Okay, so there are going to be 6 control points now, and the original degree of this object, of this line, is 1, but I'm going to bump it up to 3. So yeah, it's already 3, and I would say okay. So here is my line. Initially it had 2 control points. Now it has 6 control points, and this is how it looks. So now I'm just going to go ahead and play with the control points. So let's say I hold on to this one and I raise it by, let's say, something like 10. Okay, and we have a smooth curve. And this one, I'm going to move it down by, let's say, something like -15. How am I doing this? Directly with the gumball, I'm just selecting the point, the control point. I am clicking on the arrow where I want to move it, and I'm just typing the positive or the negative magnitude for the operation. So I would say -15 here, and I have a nice looking curve which is smooth enough. Okay, so this is, let's assume it's going to be the first edge of our canopy, which is going to span in both these directions. It's going to be something like a rectangular canopy on a hypothetical space that looks like this. Okay, so I have this curve. Now let's draw its counterpart. So this is another line that I have just traced on the same points that I had before, and I have another 50 unit length line, and I'm going to say rebuild again, and I'm going to give it the same parameters. But this line, I'm going to move in the y-axis with the distance of, let's say, 25. Okay, so I have this line here, and it has the same control points and the same degree. And let's move these control points a little bit. So for this one, I'm going to say, okay, you go down by, I would say 15. Okay, and you should go up by, I don't know, 20 maybe. Okay, so we have edges for the canopy. It looks quite all right as the boundaries are concerned. So now we have one edge, the other edge. We can just go ahead and pipe it and say that, okay, these are the 2 edges of the canopy. But we need some more, I would say, chords in the middle to help span this canopy. How would we make them, and how would they behave in a similar way that these curves do? So like if I make lines over here, like for example, if I make lines over here, ta-da-da, and ta-da-da, then they are just flat lines and they are not behaving the way I want them to, as in they're just going to make the canopy flat in the middle and my morphology does not get respected. So I need some curves between these two curves who can have similar morphologies as them and would help in the transition from one curve to another curve. In Rhino, there is a command which can help us do that, and it's called tween curves. So we are tweening, we are making curves between two curves, and these between curves are going to behave as a transition from the first to the second. So I would say tween curves, select the start and end curves, start and end curves. And now I have to say how many curves I need between these curves. So the default is 5, and I'm just going to say, okay, that's okay for me. So voila, and we have these between curves now, which are behaving as a transition from the first to the last curve. Okay, so we have the principal chords and some of the chords in the middle, which will also behave as the primary chords as such. Okay, so now is the canopy done? No, well, it's not. We need some lines in the middle which will act as mullions, or which will act as some web chords which will help spanning this canopy in a much better way. So we can just go ahead and draw the line like this. Okay, this is the first line, and the last one would be on this edge. Well, as you can see, I'm having some problems snapping to the edge. So I have to always remember that my end snap is on so that I can snap to the endpoints. And here we have the edges of the canopy. So it's almost there, but we need some lines, the mullions, that will help spanning this. Okay, how are we going to make those mullions? Is there a way in which we could just keep on drawing lines? No, that would be counterintuitive. Probably we could go to the top view and then we could draw the lines. This could be probably much more better. Well, yeah, in a way, but we still need some guiding points here, which would help us to connect those points into polylines or lines or whatever. So, okay, I need some points plotted on this curve, and for that there is a command in Rhino which is going to help me divide this curve and plot some points at equal intervals on this curve. So let's begin with that, and it's called divide. So divide this curve and this and this and this and all of them. So I'm going to select all of them carefully, and now I have all the curves that I want to divide. Press enter, and now it asks me how many segments do you want to divide this into. So imagine you have one line and you divide it into 2 segments. You would have 3 points. So if you divide it into n segments, you would have n plus 1 points. So remember that, and we are going to plot some points on this. Here we have 7 curves, so which is odd number of curves. So we are going to make sure that we have odd number of points as well, so that it's easier for us to, make some patterns on them and stuff like that. So I'm going to say, okay, if I need odd number of points, I would give even number of segments. So I would say the number of segments 10 is okay for me. So I'm just going to press enter. There are some more options here which say that I can also divide by length. Like here in this case, I'm going to divide this curve by equal divisions. but I don't know what's the distance between 2 points. Well, I can also give the length in this case, but I'm not really keen on doing that. It also asks if you want to split the curve, as in if you want to break the curve. We don't really want to do that. We just want some points on it. And then there are other options, such as if you want to mark the ends. So we say, yes, of course, we want to know what the ends are. And if you want to group the output, we are going to keep the default as no, because we don't really want to have any clusters for information yet. So I would say a number of 10 segments and all the default settings, and we have the points with us. So we have all these points which are going to help us in making the mullions, as we said before. Okay, let's make the polylines. So I'm just going to go to the top view, which is much easier for me, and I'm going to make the polyline. I type polyline and 1, 2, 3, 4, 5, 6, and 7. Okay, let's see how it looks. So, okay, it is following the curve. Well, I can also make it here. 1, 2, 3, 5, 6, and 7. Okay. Yeah. So this is going to give me something like a net, a square grid kind of canopy. But I'm not really interested in that. I want to have some patterns, and I can do that visually because I have all these points, and these points are going to help me in making the pattern. So I'm just going to go ahead and delete these lines because, okay, now I have the idea of how it's going to look. But let's see what we can do with patterns. So I'm going to say polyline again, and I'm going to select these points now. Alternate zigzag kind of mullions, which will obviously, as I know intuitively, it's going to help in spanning this canopy in a much better way, and it'll look cool too, I think. So here I have these ones, and remember to understand the process in which we are making this, like the steps that we take to perform each task, and then those steps lead to the next steps and help us in doing it. So the point is to understand the process of solving a problem, a design problem, and not just focusing on the product of how it was solved, because the process is going to help us in automating this whole thing and taking it to the next level of visual programming, where we could have the same process giving us outputs for different kinds of occasions. So we have this canopy, which is sort of displaying this kind of weird pattern, which is, of course, it's again a squared grid, but it's slightly tilted at 45 degrees. So we have the canopy now, we have the curves, and all we need to do is make pipes out of these curves. But we'll have to select the lines one by one and then pipe them. How exactly are we going to do that? Now is the time to organize things, and let's organize things into their layers. So this is how we're going to use the layer management, and by default your Rhino would have 5 to 6 different layers with the layers such as this layer 0, 1, blah 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 blah. But you can always manage these layers and customize them for your understanding, and so that you remember what is placed where in a model and you don't have much of a clutter. So I'm going to call the first layer as points, and I'm going to make a new layer, and I'm going to call it lines or curves, whatever. And the next one, I'm going to call it pipes. So I know how I got these pipes, and I know how I got these lines, and so on and so forth. Okay, now are we going to select all these lines individually, these points individually, and then put them into these? No, we're going to use Rhino to help us. So I'm going to type select points underscore SELPT. And as you can see, the moment you type select, it gives you a plethora of options of what exactly you want to select, how you want to select it, by layer, by color, by block, by whatever. So I'm going to say select point, and it selects all the points. Now all I need to do is right click on my layer and say change object layer. So which means that the points were already placed in the default layer, and now they're going to be part of the points layer. So there they are. I can switch them off, switch them on my command. I can also give a different color to them, which is not going to show because these are points. So my points are switched off. Now I can very easily select all the lines and put all of them in this layer. So my lines are in the lines layer. Here I can change the color. To change the color, I'm just clicking the color box, and then I can decide what color to give. Always keep in mind, give any color except yellow and orange, because yellow and orange are going to make it look like you have selected this geometry. Okay, because that's the default color for selected geometry. So yeah, just keep in mind that you don't use those. So I'm going to keep it as, I don't know, whatever, dark gray. And my lines are right over there. I'm just going to convert them into pipes. So I would say that I'm going to select all of them, and then I'm going to say pipe. And the pipe radius, okay, how much should the radius be? Something like 0.5 or 0.25. Yeah, maybe. Let's see. 0.5 is the radius. Now in the default, I have said that okay, I'm giving the radius and not the diameter. I don't want it to be thick. I don't want it to fit to the rail, but I want round caps. I don't want them to be open. I want some little spheres at the end points of all these lines. Okay, oh sorry, yeah. And the pipe radius is 0.5. Okay, it'll take some time because there are lots of surfaces that are going to be made. And here I have it. It looks too bulky. I'm going to give some other radius. So I'm going to select it again. I can also select all of these lines by right clicking my layer and saying select objects. And then I'm going to say pipe. And now I'm going to give much smaller radius, something like 0.15. So these are like 300 millimeter pipes by diameter. So yeah, something close to a real life situation. So yeah, there you go. These are the pipes, and the canopy looks like this. I'm going to make sure that the lines are switched off. I take all these pipes and put them in the pipes layer. I can also select all of these new geometries by saying select select the last created objects, which are these. So this is this shiny box button in the select ribbon. So there you go. We have the canopy. Now to make it look more interesting, let's see how it looks in other kind of visualizations. So let's see how it looks in the Arctic view. Okay, I have a swanky blue background, which I can change from the display. And let's say we change it to something like, I don't know, whatever. Oof, too much color. Okay, yeah. So now once you have this, the canopy, probably you would want to add some supports to it, or probably you would want to suspend it from whatever building that you have. So that's up to you, and you would follow a similar process to make the suspension cables or column supports, pedestals, and so on and so forth. So this is a canopy using the tools that we have seen so far. Some new tools that we saw, some new commands that we saw here are the tween command, the divide curve command. We also saw how to manage layers and how to manage objects that we have made on the canvas, how to avoid some clutter. And in the similar fashion that we had seen in the rest of the webinar, we have seen how to use different kinds of display options, and then the same process of view, capture to file, and then you export it into a file with predetermined pixel ratio. So I'm going to say browse, and I'm going to say 191009, and I'm going to call it Canopy, and it's on my desktop. And it takes some time to save depending on your processor. And I think it's done. Yes. So now you can use it in whichever format you want. And that's it for the canopy.
I think present attendee. Can you hear us?